Hello everyone, in this video, I'd like to show in Allen Bradley Studio 5000 PLC programming software, how can we use the PLC logic to diagnose the Ethernet IP connection status. For example, in this picture, one port I/O got a disconnect. So in the software, we can see this triangle, this warning message. If this is the standalone machine and the controller, that's the compact logics, and we are using the HMI, try to diagnose, try to detect if this Ethernet connection got a disconnect. How can we read the status of this connection? So we do need the PLC logic to read out the Ethernet IP connection status. So in this video, I'd like to show how can we implement this. The basic idea, we will use the GSV, get the system status, and we will use the entry status and read the status of this device connection. And then we will use very simple logic to read out this connection status. I will use the bool logic to show this online connecting or disconnect. Alright, in this demonstration, I will use the Allen Bradley compact logic as a controller, and I will use two stations. One is point I/O. This is a very common used I/O station from Allen Bradley. And also I will use the third end Moore device. This is also the Ethernet IP device. So we will see this GSV, they all fit. So both different brand and Ethernet IP stations, this block can read the status of them. Okay, let's go to the Studio 5000 software. This is a Rockwell Allen Bradley Studio 5000 software. And my current controller, that is a Allen Bradley L30ERM compact logic controller. And under this compact logic controller, I'm connecting one point I/O station. And within this I/O station, it has a couple modules behind. And also I have one third end I/O module. It is Moore 8-digit input, 8-digit output module. And this point I/O come from Allen Bradley themselves. And this module come from the third end. I like to these two brands, these two scenarios as an example. So to read the Ethernet IP connection status, basically there will be two methods. The first method, very straightforward. We can go to the controller variable. We can read the connection status. But this method, it has some limitations. I will introduce this after. The second method, that's more general. I will use the GSV, read the station status. I will introduce this as a second method. Alright, let's go to the first method, using the controller variable directly. After we configure the hardware configuration, and we can see under the controller tags, it projects all the variables at here. And especially for the module, it has the EDS file. Once we configure this module here, double click, so a IP address is 192.168.1.193. We can see this device, as long as you have an EDS file, the EDS file can image one connection faulted this tag. This is very useful. If you have a multiple third end EDS file module, you can use this variable as a diagnostic purpose. However, for the generic file Ethernet IP connection or for the point I/O, you cannot find this connection faulted this variable. For the point I/O, alternatively, you can find this slot status from this list. You can find this individual module status, it called slot status. So we can see each slot has a 1-bit status. This variable cannot show the actual status of this station, I mean this entire station. But when this station got lost, got a disconnect, this bit can still show something, we will see. So the 0 means the module is okay. But sometimes I feel confused, that's because not all the device is showing the 0. So you better use your existing module to have a quick look. So which device can tell you the difference when it's on, when it's off. So for example, in this module, this input and output module can tell me the actual status here. So while it's connecting, everything shows okay. This status is a 0. If this entire station lost or this module lost, So this bit will show on. So let me demonstrate this actual status. Okay. If now I disconnect, so I disconnect this station, and we can see this 2-bit will show the status, will show this 2 module lost. But this analog module, this spool, doesn't show anything. So this is hard to say when it will turn on, when it's turned off. You better use your real device to do a quick test and pick the representative one as the actual status of your station or your device. Okay? So it's showing this connecting. So we can use this spool to show the status of your device. And now I return this connection. Okay, as we can see, once the connection returned, the status shows 0. So we can use one of those spools to represent the status of this station. And in the meantime, if this module lost, it can also show 1. So for example, if I disconnect the power, this is the power module, and after this power module at the right side, this is the input and output to module. If I disconnect this power, for example, if I disconnect the power, so now this 2 module lost the power. So we can see, because this station cannot find this 2 device here, this 2 module, so it also show 1. Okay, so now I return the power. Okay, all the connection returned. So as we can see, once it return to the normal status, this is 0. Okay, this is the point IO station using the slot status. And for the EDS file, we can go to the station, and basically the EDS file will come with this connection faulted, this status. So when it's normal, this spool is a 0. And if I disconnect this station, let's see this connection faulted signal. So if I disconnect, okay, this module shows some fault. And we can see this connection faulted, that will turn on. Okay, and we can pick this spool signal to represent the connection status of this station. And we can see this mode device shows fault. Okay, this is the first method. We can pick the individual slot status or this connection faulty status to diagnose if this connection are correct in this Ethernet IP, this field bus. Alright, the second method, that is using the GSV instruction, getting system information. And this is also the uniform way usually I will implement in every project because it doesn't rely on the existing variable like this connection faulted. So I can use this GSV method to read the status for every Ethernet devices. And because of the GSV need multiple cycles to read the system status, so personally I will not recommend you program the GSV under the main task. Basically your main task, that's the cyclic main task, that's the continuous run. I will recommend you create a new task, and that new task, the periodic time could be 5 seconds or even 10 seconds. That can reduce the system workload. For example, here I will create a cyclic that is also the periodic main task, but the periodic time I can set 5 seconds, 5,000 milliseconds. Okay, and the priority, we can set a lower priority. The lower number yield higher priority, so we can set a higher number if you have a multiple other tasks. Okay, for example, here I can set 12, and if I have a high priority, I can set the number smaller than this. Okay, so I can create this cyclic task. Okay, under this cyclic task, I can add a new program. this is my main task under this cyclic task. Okay, master program. Okay, I can name that master program because we have the main program, this name already. Under this master program, I can create the new routine. Okay, we can call that EIP diagnose. And this is the main. Okay, and let's go there. And now from here, I can find the GSV command. Let's go to the right. Okay, let's find out the input output, and we will use this GSV get system value. Okay, so firstly, the class number can select the module because we are going to use this GSV to read the module status, right? So select the module. We just need to select here, and the instance name, this is also very nice. So if this GSV is used to read the status for this point.io, so we can pick this point.io. So if I expand here, we will see if we are going to read this status, we can double click. So this GSV is used to read the status from this point.io, this station. Okay, and attribute name. And from here, we can see this attribute, we can read multiple catalog from here. But basically, we only need to read the connection status. So that belongs to the entry status. That's enough. So entry status, okay? And to find out the multiple attributes here, you can click function plus F and find out the help of this GSV. So we will use the entry status. And here, the destination, this is the place to, after we read the status, which tag, which variable the status can copy to. So we can assign the one variable. So at this destination, we can call that, usually I will do using the IP address and put the name here. For example, this is the point.io and its IP address is 1.194, okay? So I could do this. So once I see this variable, I know the status of this, okay? And this is the dent actually, so I can name that DI, dent, point.io IP 194. After this, we need to declare this name, this variable as a system variable. So I can right click, click this new. So the system will automatically tell us which kind of data type for this variable. Okay, this is the dent. Okay, we just need to create. And the scope, so for this variable, this dent variable, I can declare this variable as this local, cyclic task local variable. Okay. So I declare this variable as this local variable. Okay, this is the first station. Now let's create the second one. So second one, still the GSV, and the class name again, we will select the module. And the instance name, we will select the second station, more, this station, okay? And the attribute, entry status, destination. So this destination, I can declare the name more 8DI, 8DO, and that IP address is IP 193, okay? And then click new, declare this variable. And the same thing, dent, double integer, and declare as a local variable, master program. Okay, so now let's finalize all the editing. Again, we are doing the online editing. So under the correct status, we will see these two integers is showing this number. This is the decimal value. If we go to the local variable list, and we will see this value is showing like this. But if we switch this style to hex, so we will see this is 4,000. 4,000 that means running. So if we go to the help, this is the get system value. If we scroll down, and we find out this GVS objects, and then because we are selecting the module, let's go to the module. And from this entry status, we can see this is the code. That 4,000 under the hex, this pound, that means running. Okay, Basically, if the system is doing some weird or doing some wrong, that is not equal to 4000. Or reversely, if this value equal to 4000, that means this station is running properly. If not, that means the system is not doing correct. So basically, we can compare if this integer value equal to this value. That means the system is doing correct. If not, this is not correct. So we can compare this entry status value. Okay? So if we go back to the program, and if we go to the program code here, then we can add the program here. We can use the compare, use the equal. So if this integer value equal to 16384, that means this station is running. Okay, so we can name that bool .io, and this IP address is 194. Okay, and here we can declare this variable. This time we will select slightly different. Here I will select as the controller variable. So every other task and program can use this variable. Okay, I declare as the controller variable. So this variable will be at here. Create. And the same thing. Compare. Equal. And this variable. And compare to 16384. Okay, this is integer. And output. Bool 8di 8do underscore IP 193. Declare this variable. Same thing as the controller global variable, controller tags. Okay, and this is bool. Great. Okay, let's finalize. All right, after we finalize, we will see now, well, the system is correct, so it's equal to 16384. So this connect, this variable, that means correct. So if I disconnect one station, firstly, I can disconnect the more device. So I disconnect. And after the 5 seconds, basically this task is running 5 seconds as a periodic time. So this variable will turn off. So we can name this variable as the online status or online correct. So while it's off, that means this station lost. Okay, if I return this station, okay, after for a while, we will see this bool turn on. That means online come back. Okay, and let's disconnect this .io. Okay, let's disconnect. As we can see, this bool turn off. Online loss. So also from this online diagnostic here is showing connecting. Okay, the software found this station lost. Okay, now I return this connection. So after I return this cable, we will see this online bool show on again. Okay, so this bool represent the online connection status. Okay, and now if I disconnect the power for this module, and let's see what's going on will be. If I disconnect the power, so we will see this status only represent this station. If the sub module has something wrong, this module cannot detect that because this is the entry level. Okay, entry status. If we go back to this online help, we will see it only represents this module status. Okay, basically we only need to care about this entire station if that lost or that connection cracked. So this 4000 represent running properly. Okay, we can see. Okay, I'm gonna return this power. Okay. Okay, the status return. Let's try it again. If I disconnect this point IO, after a couple seconds, that depends on the cyclic time you set. So this spool will turn off. If I return this connection, okay, after a couple seconds, we will see this status return, and this station got recovered. Okay, it's showing running. That's the 4000. If we go to this variable again, go here. So the correct status showing 4000 hex number. If I disconnect this more device, and we will see this more device shows 3000. So if we go here, we will see 3000 means connecting. Okay, same thing for this port IO. So if I drop the connection again, so it's showing 5000. Okay, 5000 is shutting down, or sometimes it's showing the 3000 or 5000 shutting down or connecting. Okay, we will see some cases showing the 3000 or showing the 5000. Okay. All right, now if I return the connection, we will see the point IO return 4000 back again. So it's showing running. And more that also return showing 4000. Okay, this is using the GSV module and entry level very easily to read the status and uses a comparison. Okay, make sure this comparison, that's the 4000 hex number or this 16,384, this decimal value. And don't forget to call this GSV. Personally, I recommend you can use one individual. This is a cyclic task, around 2 seconds or 10 seconds, and the lower priority to read this module or connection status. Okay, this is the two methods reading the Ethernet connection. One method that's using the GSV, one method that's using the built-in this controller tag, this connection faulted status or this slot status. All right, that's for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.